Hey guys, in this lesson we would describe lines using vectors. Lines using vectors can be described in both R2 and R3, that is 2 space and 3 space axes. So far in the previous unit we have discussed how to mark points in 2 space and 3 space, and we also learned how to draw lines in 2 space and 3 space. In this unit and in this particular lesson we would be describing the equations of lines. Equations of lines can also be described in both 2 space and 3 space. We would be first discussing equations of lines in 2 space. When it comes to equations of lines in 2 space, it's basically of 3 types. One is called the vector equation, one is called parametric equation, and there is another type called Cartesian equation. Cartesian equation has another name called scalar equation. In this lesson, we would be talking about vector and parametric equations only, and we will discuss about Cartesian equation in the following lessons. Whenever we are writing the equations of lines in 2 space, using vector form or parametric form, there are 2 different ways to do that. One is that if we are given 2 points, we use those 2 points to write on the equation. Another way is that if we are given 1 point and a direction vector, then we use these 2 things to write the equation. So basically, in order to write on the vector or parametric equation, we need to have one of these 2 conditions. The first condition is that either we should have 2 points given, or we should have 1 point and a direction vector given. We already know what is a point in a vector. If you want to refresh your memory, you can watch the previous unit videos. That was Introduction to Vectors. But here we would discuss what is a direction vector. Now direction vector is represented with M, with this vector arrow on top because it's a vector, and it is written as a point coordinate form. So A, B. Always remember, for a direction vector, it's nothing but it's just a line. It's a vector line that has its origin at the origin of axis and its head at AB. So basically we can write it in a different way. Vector line that has its tail. So we can call the origin or the start point or the tail at the origin of the axis and its head at A, B. And we know AB is going to be a point. One more thing you have to remember here is that the direction vector is always parallel to the line that you're writing the equation for. Let's quickly summarize this. So basically what we require in this particular lesson is to write in the equations of lines. And equations of lines can be written in 2 different conditions. The first condition is that you're given 2 points. The other condition is 1 point and a direction vector is given. We know what is meant by a point, but we don't know what is meant by a direction vector. So a direction vector is just a line that has its tail at the origin of the axis and its head at any point AB. And direction vector is always parallel to the line that we are writing the equation for. Let's understand this with a diagram. Let's say we are given this axis and we are required to write on the equation for this line. Now to write on the equation for this line, and we are considering condition number 2, that is when a point is given on the line. So let's say we're given this point on the line. Point given on the line means you'll be given the coordinates for the point. So let's just consider it x and y for now. And another thing you should be given is the direction vector. Direction vector is represented as AB. This AB point will be anywhere that when you join this origin and this point, you should be able to get a vector line that is parallel to the line that you're writing the equation for. So this is called direction vector. Why is direction vector so important? You remember in previous grades when you write on the equation of lines, you always need the slope. So direction vector is nothing but another way of saying slope. Slope of this red line and slope of this yellow line should always be equal. That's why we say that the direction vector is parallel to the given line that you're writing the equation for, because parallel lines have same slopes. Or we can say parallel lines have the same direction vector. So always remember that whenever we are given the direction vector and if we are given the point that lies on the line, we will be able to make the line of our choice for which we are writing the equation. Let's draw a line with given point P 4, 3 and a direction vector M equal to -7, 1. How do we mark a point in Cartesian axes? Point is 4, 3, so x value, let's say 4 is here, 3 is here, so the point is going to be here. So this is the point P. We have a direction vector M that is described by -7 and 1. We know direction vector origin is always at the origin of the axis, or the tail is always at the origin of the axis, and the head is always at the given point. Here the given point is -7 and 1. So let's say -7 is here and 1 we have is here. So this is the point given to to us. This point is representing the head of the direction vector. So when we are making the direction vector, it has to start at the origin and it has to connect to the point forming the head of the direction vector. This is the direction vector given to us. Now, in order to make this line that passes through this point P and that has a direction vector M, all we have to do is just make a line going through P parallel to the direction vector. You can use a ruler. So this is your line that you are going to be writing the equation for, or this is the line that we are going to be describing. And how do we describe lines? Is by writing their equations. We can write down two equations of this line. One can be written in vector form and one can be written in parametric form. Let's call this line L. So we're writing the equation of line L. Before writing the equations, we need to know their general form or the general way of writing the equations. So vector equation general way is R equal to R naught plus Tm, where R naught is the point that lies on the line. Here it's going to be describing the P point, and M is the direction vector of that line that we're writing the equation for. T is just a constant. In this particular example, if I want to write on the vector equation, I would write down R vector is equal to R naught. R naught is going to be the coordinates of point P, and point P is given to us as 4 and 3. So we would write down R naught as 4, 3 plus T is the constant, M is the direction vector, and the direction vector coordinates are given to us as -7 and 1. So we would write down here -7, 1. And this is the vector form of equation. We just need a point lying on the line and we need its direction vector. We can write down the vector form of equation in component form as well. We can separate the vector equation in components. So this R vector can be written as x, y coordinate components. R naught is described as x naught, y naught. And this -7, 1 is nothing but AB. AB we know are the coordinates of direction vector. So we can describe the vector equation in this form or in component form. That doesn't make a difference. Now coming to the parametric form is nothing but you just have to separate out your x and y's. So x is going to form a separate equation just with x's. We would have x equal to x naught plus ta. Y would be written as separate equation as well. So y is equal to y naught plus tb. Now for this equation example that we're doing right now, we have this is the equation. We can write on parametric form of the equation, and that would be x equal to 4 minus 7t and y equal to 3 plus 1t. And this is nothing but called the parametric equation. In this example, we learned how to write down the vector in parametric equations using a point and the direction vector. So point and direction vector, that is condition number 2 or type 2 question, is already covered up. Now we would learn how to write on vector and parametric equation using 2 points. Now let's say you're given a question. Point A is -1, 5. Point B is 6 and 11. So you're given 2 points and you have to write on vector and parametric equation. We know the general vector equation looks like this and the general parametric equation looks like this. We also know that this AB represents direction vector. So the first or the foremost important thing here is to find out the direction vector. Then only we will be able to complete the vector and parametric equations. Now I told you earlier that M or direction vector is nothing but slope. So the way we have to find out the direction vector is the same way as we find out the slope. We know slope is rise over run. So you're given point A, -1 and 5. Let's say it's here. And you're given point B, that is 6 and 11. Let's say it's here. This is point A, this is point B. You are writing the equation of a line that is connecting point A and B. We need to find out the direction vector, and direction vector is nothing but the slope. Slope is represented as rise over run. Rise is the change in the value of y when you go from A to B. So this is the rise and this is the run. In other words, we can just say rise is the change in y and run is change in x. Change in y is y2 minus y1. So if you're going from point A to B, just have to do 11 minus 5, and this is 6 minus -1. That gives you 6 over 7. Now this is how you find out the slope. But how do you write it down in the direction vector form? Direction vector form is A, B, where A represents the run because it's your x value, and B represents the rise because it's your y value. So A is change in x, and b is change in y. Change in x is 7, change in y is 6. So we would write down the direction vector as 7, 6. Now going back to the question, we have direction vector that we have already found out, 7, 6. We have a point given A, -1, 5, and we have a point B given as 6, 11. We need to use these three things in order to write down the vector and parametric equation. But for writing vector and parametric equation, we definitely need a direction vector. Out of the 2 points, we can use any one point of our choice. So vector equation would be r vector equal to r naught plus t a b. R naught, you can pick any point, A or B, it's up to you. It has to be any point lying on the line that we're writing the equation for. So I'm going to pick a point, -1, 5, and this is 7, 6. So this is how we get our vector equation. To write down its parametric equation, I just have to separate my components. So I have to write down x equal to -1 plus 70 and y equals to 5 plus 60. And this is how I get my parametric equation.